Welcome back, focused learners, to another explainer. Today we're diving into a genuinely fascinating topic that is absolutely poised to change the game for academic and scientific research. We're unpacking a breakthrough paper called Multi-Turn Agentic Scientific Literature Search via Workflow Induction, authored by Jisun Nini and a brilliant team over at the University of Illinois at Urbana-Champaign. I mean, think about the history of literature search for a second. Honestly, the basic mechanics really haven't changed much since the early days of Google Scholar. We are still leaning heavily on static keyword matching. But this UI/UC team, they've just introduced a true paradigm shift. If you've ever felt totally overwhelmed by the massive ocean of scientific literature and just intensely frustrated by how clumsy our current search tools are, you're absolutely going to want to stick around for this explainer. So let's just start by addressing a frustration we all share. Why is finding that one perfect research paper so incredibly agonizing? We all know that scientific literature search is literally never a simple one-and-done query. It's a messy, iterative, totally exhausting rabbit hole. The core issue here is that human research intents are what data scientists call underspecified. When you start a deep dive, you often don't even know exactly what you're looking for yet, mainly because you haven't read the foundational papers that actually define your keywords. It's a total chicken and egg situation. Your needs depend heavily on your preferences, and they are constantly evolving as you interact with the material. You might start off looking for a specific biological mechanism, read one abstract, follow a super interesting citation, and boom, your entire thesis direction just pivoted. You don't fully know what you need until you actually start reading. It's a living, breathing process, not just some static data retrieval task.
So here's our quick roadmap for today's explainer. Number 1, the literature search struggle. Number 2, why current AI fails. Number 3, enter PaperPilot. Number 4, the power of workflows. And we'll wrap it all up with number 5, the astonishing results.
All right, let's officially kick things off with Section 1, the literature search struggle. Like we just talked about, it's a remarkably messy, living process where your goals are constantly shifting on the fly.
Which brings us right into Section 2, why current AI fails. Why do our shiny, highly advanced modern tools completely drop the ball when handling that messiness?
Well, the core of this failure really comes down to two things: transparency and trust. Existing search agents usually rely on these fixed pipelines, or implicit language-only reasoning. Basically, they create a massive black box. You ask a complex scientific question, the AI hums away somewhere in the background, and then it just spits out a list of papers or a synthesized answer. But you have absolutely zero idea how it actually arrived at those conclusions. And for a rigorous scientist, a black box is incredibly dangerous. If you can't verify the AI's methodology, there is no way you can trust its conclusions for a peer-reviewed paper. If it hallucinates a connection, your reputation is the one on the line. But the alternative, which the team at Illinois set out to build, relies on explicit, editable search workflows that are completely transparent. The entire methodology is right there, completely visible. And that brings us to Section 3. Enter PaperPilot, your new interactive and highly transparent research co-pilot. So the research team introduces PaperPilot as this revolutionary multi-turn literature search agent, and the whole thing is based entirely on a concept called workflow induction. To wrap your head around workflow induction, think about a GPS navigation system. A basic AI acts kind of like a teleportation device. It just blindly drops you at a destination you might not actually want and offers no explanation of how you even got there. Workflow induction, on the other hand, is like a highly advanced GPS. It doesn't just hand you the final destination, it generates a totally transparent, turn-by-turn route. It frames the entire search as this editable, step-by-step blueprint of actions. And because you can see the exact route it's planning to take to find your papers, you can literally drag and drop detours, correct its path, and guide it based on your evolving needs. All right, moving to Section 4, the power of workflows. Let's actually pop the hood and see how this technology is built. How exactly does this tool go out into that vast ocean of literature and bring back precisely what you need? It runs on a multi-turn, human-in-the-loop process. First, it starts when you input a user query and an anchor paper just to establish a solid baseline. From there, PaperPilot constructs what's called an executable directed acyclic graph, or a DAG. Now, DAG sounds like a lot of heavy computer science jargon, but it really just means a clear, transparent flowchart of logical operations that only move forward in one direction. The AI presents this draft methodology to you, it executes the map, gathers your feedback on those initial results, and then actually refines both your query and its own workflow map for the very next turn. It's not trying to replace the scientist here, it's just presenting a draft methodology for you to actively approve, reject, or tweak. Now, to build that flowchart, PaperPilot relies on some very specific paper search operators. You know how standard large language models often fail at research because they try to guess or hallucinate what papers might exist based on their training data? Yeah, PaperPilot doesn't guess. It actively deploys verified tools. To build your customized research blueprint, the AI can do a strict keyword search, execute a citation expansion to pull related works, apply filtering and scoring algorithms, re-rank the results based on what you said was important, and even perform direct evidence extraction. It is essentially automating the exact meticulous grunt work you would normally be doing manually across 50 different browser tabs. But building an AI that's actually capable of intelligently stringing all these tools together is remarkably difficult. The researchers pulled this off using a really unique training method. First, they used supervised workflow imitation, which basically means the AI learned the ropes by mimicking ideal, successful search paths. But the real genius is in the second half, preference optimization over controlled workflow corruptions. Think about how we train airline pilots. You don't just let them fly in perfectly clear weather, right? You put them in a flight simulator and intentionally shut down an engine to see if they can recover. The researchers did exactly that. They deliberately threw the AI off course during training. They introduced dead ends and workflow corruption so the AI could learn resilience. It learned how to flawlessly course correct and realign with complex scientific intent, even when a search query went totally off the rails. Which brings us to Section 5, the astonishing results. Let's dig right into the benchmark data. To prove this transparent architecture actually works, the researchers pitted their model, PaperPilot 9b, against a super powerful baseline QN 3.59b toolset under interactive multi-turn conditions. And the performance leap is just staggering. The first crucial metric here is hit at 5, which measures how often a highly relevant paper appears within the very top 5 search results. The baseline agent scored a 58.0, but PaperPilot's workflow induction method caused that accuracy to absolutely skyrocket to a 77.0. In real-world terms, this means instead of digging through pages and pages of mediocre search results, that exact golden paper you need is sitting right at the top of page 1, ready for you to cite. And that momentum carries right over to the mean reciprocal rank, or MRR. This metric evaluates where the absolute first relevant result appears in the overall list. It climbed massively from 47.5 to 59.4. Think about what that actually means for your daily life as a researcher. That jump translates directly into hours of saved time every single week. You're spending significantly less cognitive energy just scrolling past irrelevant, low-quality junk to find your first useful nugget of info. The signal-to-noise ratio is vastly improved. We also see a really substantial increase in the overall ranking quality of the batches provided. The NDCG at 10 metric is a bit of dense data science phrasing, I know, but simply put, it evaluates the relevance of the entire top 10 list of results combined, and it leaped from 26.8 to 32.5. This proves that PaperPilot isn't just getting lucky and finding one good paper while handing you garbage for the rest. It means the AI is consistently curating a top-to-bottom reading list where almost every single link is highly valuable to your specific, nuanced thesis. But guys, here is the absolute mic drop from the whole study. Remember that flight simulator analogy we talked about? Remember how the AI was intentionally trained to recover from errors? Well, the base agent experienced workflow execution errors 9.5% of the time, meaning it would just get confused, stuck in a loop, or totally fail to execute a search tool properly. With PaperPilot, those workflow execution errors plummeted all the way down to 0%. Zero. It executes the research map flawlessly every single time. Which perfectly leads us to the ultimate takeaway, straight from the research team. Explicit, editable search workflows provide an effective and controllable interface for aligning literature search agents with complex scientific intent. We have successfully shattered the black box, folks. The era of just blindly trusting AI search results is totally over. AI shouldn't just hand you an unverified answer. It absolutely must give you a clear, editable map of exactly how it navigated the literature and let you take the wheel whenever you need to. So, I want to leave you with a final, provocative thought regarding your own deep work. If your AI search agent suddenly opened up the black box, showed you its exact step-by-step workflow, and let you actively edit its methodology in real time, what hidden research connections would you discover today? How much faster could you innovate? PaperPilot strongly suggests that the future of scientific discovery isn't about AI replacing the researcher. It's about handing the researcher the ultimate transparent steering wheel. Thanks for joining me on this explainer, Focused Learners. Stay curious and keep exploring.